Hello everyone, welcome to lesson 7-2, simplifying algebraic expressions. In this lesson, we will identify parts of an algebraic expression and we will use the distributive property to simplify algebraic expressions. Let's dive right in by defining the parts of an algebraic expression. When addition or subtraction signs separate an algebraic expression into parts, each part is a term. So here we have a term, another one, and another one. So we have 4 terms there. The numerical part of a term that contains a variable is called the coefficient. So this is our coefficient right here, and that's our variable. So let's see, in this expression we have the coefficient of x is 3. This expression has 4 terms, as I just mentioned, and the coefficient of x is 1 because x equals 1x. So we know that there's a 1 in front of it, but anything multiplied times 1 is simply that, right? So x times 1 would just be x, or 1x. So we don't have to write the 1 in front as a coefficient. In this chapter, we will work only with terms with an exponent of 1. In this case, like terms are terms that contain the same variables, such as 2n, 5n, or 6xy, and 4xy. All of these terms are to the power of 1. If, let's say, 2n were 2n to the power of 2, and 5 were, and this term were 5n to the power of 3, they would not be like terms and they would not be able to work together. They would not be able to add or subtract with one another. So we have to, a term without a variable is called a constant. So you can see here that because it doesn't have a variable, this number will be 3 no matter what. The coefficient here will change once we identify what the value of y is. So that's why this is a coefficient and a variable. This is an undefined term. But this one's defined. It's 3 no matter what, and that's why it's a constant. Now let's use what we just learned to identify the following terms in example 1. So we're going to identify the like terms in the following expressions. For A, we have 3x plus 4y plus 4x. 3x and 4x are like terms since the variables are the same. B, 5x, 7x are both the same. They're both like terms, so they can be added or subtracted together. And 3 and 4 are constants, and we can simply add those two together. So to simplify this one, we would have 5x plus 7x is 12x, plus 3 and 4 is 7. So in simpler terms, and this is what we're working towards, we would have 12x plus 7. Now we're not being asked to simplify yet, we're simply being asked to identify. So go ahead, look at this expression or number sentence and identify your like terms. Pause now, try it, and then play for the answer. Okay, I hope you paused your video. Let's see here. We have negative 4x, and then we have a 2x here. Those two are like terms, and then we have 2y and 3y. So we would write negative 4x and 2x are like terms, and 2y and 3y are like terms. So those would be able to work together. At this point, you could use commutative property when you have an expression like this. Shift the like terms around, or shift the terms around so that the like terms are next to each other, and then simplify. So you would have negative 4x plus 2x, we make it negative 2x. So that would be negative 2x plus, then you have your 2y and your 3y together makes 5y. When working with subtraction, it might be helpful to rewrite a subtraction expression using addition. So as they suggest here, to identify the terms, like terms, coefficients, and constants in the expression. So we have 6y minus 2y plus x minus 5. Now you can rewrite it, a subtraction expression using addition so that it helps you identify the terms on an expression. So what they mean is you can write 6x and negative 2y. See that? 6x and negative 2y. And x and, or plus, negative 5. Okay? If you write them all as addition and you place your negative terms inside of brackets, it can help you group them together. Okay, then you use the identity property, and the terms are 6x minus 2y, x, and negative 5y. The like terms are 6x and y. The coefficient are 6, negative 2, and 1, and the constant is simply negative 5, as you see that you have there. So let's try that. Now we don't have to use addition, but go ahead, pause the video, and try this one on your own. Pause now. Okay, I hope you paused the video. Now let's see. We have 3n plus 5n minus 6m plus 2. We can say that we have 3n. It has no like term. 5m and negative 6m are like terms, and 2 is our constant. So we will put this one as our constant. These two as our like terms. And we do have three coefficients. We have the 3, the 5, and the 6. So our coefficients are 3, 5, and negative 6, as you can see here. Okay? And our terms are 3n, 5m, negative 6m, and 2. Those are all the terms in this number sentence. And when you go and you look at the number of the expression, we have a 3 next to the variable, a 5 next to the other variable, and a negative 6 next to this variable. Those are our coefficients. Okay, as I wrote them down here. Now for the fun part. Simplify algebraic expressions. An algebraic expression is in simplest form if it has no like terms and no parentheses. When you use a distributive property to combine like terms, you are simplifying the expression. And that's what we're going to practice now. This is actually kind of fun if you know how to work with your like terms, your integers, multiplying, dividing, subtracting. It all comes together now. But take a look here at how it works, okay? Where we have our like terms 4x and 2x. Those two will make 6x. And then we have a constant that has no other constant to be added to or subtracted from. So it simply becomes 6x plus 6. You see? 4x's, 2x's becomes 6x, and then plus 6. All right. Always put the constants towards the end and the numbers, the coefficients with their variables in the beginning of the number sentence. As you can see, they all end like that. Okay? Here we have 4n plus negative 4, or just simply 4n minus 4. This is how I would write it in simplest form. Go ahead, take a look at how these were done. I'm not going to take up any more recording time for that, but you can pause and look through them. Once you've done that, go ahead, pause the video, and try these three. Okay, if you haven't paused the video, go ahead, pause it now, and try these three on your own, and then play the video. I'm going to go ahead right now, assuming that you already completed them, and start showing you how to do them. Let's look at 3a. In 3a, we have 1, 2, 3 terms. We have 3 terms. We have 2 terms that have coefficients, and the variables are the same. So those two are like terms. So let's go ahead and use and shift them around so that they're next to each other, the like terms. So we have 4x minus 3x plus 6, right? All I did was move the terms around so that they can now work with their like terms. And we go ahead and we do simple math. 4x minus 3x is just simply 1x, but we write it just x. We don't have to write it 1 in front of it, plus 6. And that's completed. Let's try now 3b. Again, let's look at the expression, and we have 2m plus 3 minus 7m minus 4. We have 4 terms. 2 with coefficients, 2 variables with coefficients, and 2 constants, 4, -4, and +3. So again, let's move them around. 2m minus 7m plus 3 minus 4. Okay, you can see that I grouped the 2m minus the 7m, and then I grouped the plus 3 minus 4, right? And 2m minus 7m is negative 5m. And then here's the tricky part. I have a 3 minus 4. That's going to become minus 1, -1, correct? Because I'm taking more away than what I have. So you can write plus -1, or you can just write simply -1. Okay, this would be an acceptable answer. This would also be an acceptable answer. -5m plus -1. And now for 3c. You can see here we're being given an opportunity to use distributive property. And let's do that. Let me write the question down first. 4 times q plus 8p. So there's 4 of those. Plus p. Okay. 4 times q and 4 times 8p. 4 times q will give me 4q. Plus 4 times 8p will give me 32p plus p. Remember this last p has a 1 in front of it. So it's 32p plus 1p. So now I have 4q, or it is common practice to put the larger coefficient with the variable first, and then the smaller coefficient after, and then finally the constant. So let's do that. Let's just do it the way it's normally done. So I'm going to do these two first, and I get my 33p plus 4q. And that's simplified. We can't go any further than that because these are not like terms, and you cannot add or subtract terms that are not alike. And finally, for the last example, we are going to look at algebraic expression in context, financial literacy. You have some money in a savings account. Some money. There is your variable. See? There's your ambiguity. What your variable. Your sister has 25 more than you have in her account. So it's a plus 25. Right? Or you can subtract it. Depends on what the question is. Write an expression in simplest form that represents the total amount of money in both accounts. Okay, so some money, x, or m for money, right? Doesn't matter what variable we use, but we can have x plus 25, and that's what your sister has. Because it says on there that your sister has 25 more. So this is your sister. That's the amount of your sister. And what do you have? Okay, you can have an amount, a different variable, minus 25. But let's see here. In words, amount of your money plus amount of your sister's money. Let x represent your money. Let x plus 25 represent your sister's money. See, like I said, your sister's money because it's your money plus an additional 25 that she has. So as an expression, what will be the total number of money? Well, x is your money and your sister's is your money plus 25. You see that? This is something that some people often struggle with. Let me explain that again. X is your money, right? So x, we have your money. And then we know that your sister has 25 more than you, so it has to be plus your money again, plus 25. And this right here alone is your sister's money, and this is your money. Got it? Okay, and that's how we would represent it algebraically. And you can see that there. So then how do we simplify? Well, we have 1x plus another x. It's going to give me 2x's plus 25. And this expression represents the total amount of money in both accounts. Okay, I hope that made sense to you. Let's try 4a and 4b. Now, this would be a good time to pause the video and try it on your own, or pause it after we read it together. 4a. Mato and Lola both collect stamps. Lola has 16 more stamps in her collection than Mato. Write an expression in simplest form that represents the total number of stamps in both collections. Let's use Mato as M. Okay, Mato is M. That's the amount he has. And Lola has Mato's. See, she has 16 more stamps in her collection than Mato. So she has the amount Mato has plus 16 more. So she has Mato plus 16. Right? And then if we wanted to write it all as one expression, to find the total, we have Mato plus 16. That's Lola. So then we have two M's, right? Here's one, here's the other, plus 16. And that's the expression. That could be factored, and you guys know that. But that's not what we're doing. And then for 4b, Derek has as many stamps as Mato. So they have the same amount, has as many stamps as Mato. Okay, so now we have Derek is equal to Mato. Write an expression to represent the total of all three collections. Okay, so these two have the same value. D is M. So we can just simply do 2 times Mato. And that would give me both of them. That would give me Derek's and Mato's. Plus, I'm not even sure if I'm saying this name right, by the way. It could be Mato, like tomato. But I'm just going to say Mato because Mato doesn't sound right to me for some reason. But anyways, we have 2 of them because it just said Derek has as many stamps. So Derek and Mato are the same. So we can just say 2 Matos. They're both Matos. Plus Lola's, which is, we know that it's 16 more than Matos. And when we simplify, we get our 3m's, right? We have 2 right here, plus another one, 3m's, plus 16. And that is our final answer for that. Now, it didn't have to be m. Remember, you can use x, you can use a different variable. Now, I like to use the first letter of their names. It just makes more sense to me. It helps me keep track. Okay, everybody. That is your math lesson for today. Here is your guided practice. I will see you guys next class. Bye for now.